All right, this is Unit 7, Lesson 1, Trigonometric Functions and Acute Angles. So our lesson essential question is, how can ratios of lengths of sides within right triangles help determine other lengths and angle measures in the triangle? At the end of this lesson, we'll be able to use trigonometric functions. Concept: trigonometric ratios. The three sides of a right triangle are referred to as the hypotenuse and two legs. The Greek letter theta is often used to represent an acute angle in a right triangle. Angle theta is an abbreviation for the angle with measure theta. So here I have my angle theta. My hypotenuse is always across from my right angle. My adjacent side is the one that's right next to the angle that I'm looking for. The other side is the hypotenuse, and then the opposite side is the opposite from the angle that's given. So there are 6 basic trig functions of the angle theta. I have sine, which is opposite over hypotenuse, the cosine, adjacent over hypotenuse, tangent, opposite over adjacent. The reciprocal trigonometric functions of the angle theta are formed by exchanging the terms in each ratio. So cosecant is the opposite of sine, becomes hypotenuse over opposite. Secant, which is the reciprocal, is hypotenuse over adjacent. And cotangent is the reciprocal of tangent, which is adjacent over hypotenuse. There is an easy way to remember these. It's called SOHCAHTOA. So it's SOHCAHTOA. Okay, so S is opposite over hypotenuse, so SOH. Cosine is adjacent over hypotenuse, CAH, and then TOA is tangent, which equals opposite over adjacent. All right, example 1, right trigonometric ratios. So given the right triangle below, write the 6 trigonometric ratios for the given angle with measure theta. Okay, so here's my measured theta, here is my hypotenuse, here is my adjacent side, and here's my opposite side. Okay, so they were nice and they gave us all of the measurements. Okay, so sine is opposite 21 over my hypotenuse, which is 29. My cosine is my adjacent 20 over my hypotenuse of 29. And my tangent is opposite 21 over my adjacent 20. The cosecant, I literally just flipped the sign. Secant, I flip my cosine, and cotangent, I flip my tangent. Okay. So let's try it. Write the 6 trigonometric ratios for the given angle with measure theta. Remember SOHCAHTOA. So SOH, that's my opposite. So here's my hypotenuse, here's my opposite. So 5 over hypotenuse, which is 13, cosine, CAH, so adjacent over hypotenuse, and then my tangent, OA, is opposite over adjacent. My cosecant is just the reciprocal of my sine. My secant is the reciprocal of my cosine, and my cotangent is the reciprocal of my tangent. Yes, it really is that simple. All right, write the 6 trigonometric ratios for the given angle with measure theta. 37 is my hypotenuse, 35 is my adjacent, and 12 is my opposite. So sine, SOH, opposite over hypotenuse. Cosine, CAH, cosine's my adjacent over my hypotenuse. My tangent, TOA, opposite over my adjacent. I flip cosecant, I flip for secant, then I flip cotangent. Keep them as improper fractions, that's completely fine. All right, example 2. Use one trigonometric ratio to find another. Knowing that tangent of theta equals 15/8, what are the other trigonometric ratios for theta? So you can use one trigonometric ratio to find the other 5. So I was given tangent over theta, which means I easily know cotangent because it's just the reciprocal. So that one's going to be 8/15. Okay, so the first step is draw a triangle. Anytime you have something like this, draw a triangle. You can even just have one set up that looks like this, the one that's given, and then you can just fill in your hypotenuse, your adjacent side, and your opposite side. Okay. So step 1, use the definition of the tangent ratio to draw a right triangle with angle theta. So here's angle theta. Remember that my opposite is 15 and my adjacent is 8. Step 2, I use the Pythagorean theorem to find the hypotenuse because we need to know what this green side is in order to figure out the rest of the ratios. So remember Pythagoras' theorem, a squared plus b squared is c squared. It doesn't matter which one's a and which one's b, but your c is your hypotenuse. So a they used as 8 and b was 15. So 8 squared plus 15 squared equals c squared. When I simplify that, I get 17. Now that I have all of my sides, I can find my sine, my cosine, my cosecant, my secant, and of course I already knew my cotangent. All right, so let's try it. What are the trigonometric ratios of an angle with measure theta in a right triangle in which sine theta equals 24/25? So we know that 24/25 is going to be sine. Okay, and we know that cosecant is going to be 25/24. So sine is opposite SOH, SOHCAHTOA. So sine is opposite over hypotenuse. So when we have a triangle, I'm going to draw my triangle. My hypotenuse is 25. My opposite angle is 24. So I need to find my side. So here's my triangle. We know that we need to find the missing side, which is A. So that's a squared plus b squared equals c squared. This works, remember, because it's a right triangle. So a squared I'm missing. E squared is 24, so 24 squared, and c is 25 squared. Okay, so 24 squared gives me 576. 25 squared gives me 625. So a squared is 625 minus 576, which is 49, which means a equals 7. Okay, so 7. So then I have SOHCAHTOA. So sine equals my opposite over my hypotenuse. My cosine equals my adjacent over my hypotenuse. My tangent equals my opposite over my adjacent. Cosecant is the inverse of sine or the reciprocal. Secant theta is the reciprocal of cosine, and cotangent theta is the reciprocal of tangent. Right, example 3, find a missing side length. So a fire truck has an 84-foot ladder extended against a building, forming a 55-degree angle with the top of the truck. The truck is 8 feet tall. The firefighters are trying to reach a window that is 75 feet above the ground. Will they be able to reach the window using the ladder set at this angle? Okay. So first we want to sketch a diagram to represent the situation. Label the sides and angles of your diagram with all of the known information. So we know that the wall is here. We know that there's an additional 8 feet off the ground. We know that this is a 55-degree angle and it's an 84-foot ladder. So 84 is my hypotenuse. The wall plus 8 is going to be my, I already have my theta, so this is my adjacent side and this is my opposite side. Decide which trigonometric function to use. You are given the hypotenuse and you are trying to find the length opposite the angle with the measure of 55. So I'm trying to find the wall length. The ratio that relates the opposite side of an angle to the hypotenuse of the right triangle is the sine ratio. So let x represent the length of the side opposite the 55-degree angle and write an equation, sine 55 equals x over 84. Solve for x, so I have to multiply both sides by 84, so x equals 84 sine 55, and then you use a calculator, which gives you 68.8 feet. Okay. Find the height of the building on the building that the ladder will reach. The height the ladder will reach is the side length of the triangle plus 8 feet for the height of the truck. So it's 76.8 feet. So the ladder will extend to a height of about 76.8 feet, which is longer than 75. The firefighters will be able to reach the window 75 feet above the ground. So let's try it. The sun shines at a 60-degree angle to the ground. How long is the shadow cast by a 20-foot flagpole? All right, so when we're drawing this, my height of my flagpole is 20 feet. Here's my sun. So it's a 60-degree, it's hitting the ground at a 60-degree angle. So according to the wording, that's where it kind of gets confusing. The sun shines at a 60-degree angle to the ground. So here's my ground, 60-degree angle. Here's the sun that's coming down. So I'm looking for my shadow, which is right here. So I want to use the tangent of theta, which is my opposite over my adjacent. So my opposite is 20 feet. So tangent of 60 equals 20 over my adjacent, which is x. Okay. So what I need to do here, if I multiply by x, that gives me x. Tangent 60 equals 20, and then x equals 20 over tangent 60. So x equals 11.5 approximately. 20 divided by tangent over 60 gives me approximately 11.5. All right, example 4, evaluate trigonometric ratios in special triangles. So triangle MNO is a 45, 45, 90 triangle with side lengths OM equals 2. What are the 6 trigonometric ratios for angle N with the measure theta? Okay, so this is an isosceles triangle, an isosceles right triangle, so the legs are congruent. So we know that OM, okay, so they gave us MNO is a 45, 45, 90. Okay. OM is 2, the side length. Okay. I find the hypotenuse. So remember the legs are congruent, so that means ON is also 2. So 2 squared plus 2 squared equals C squared. So C equals the square root of 8, or 2 times the square root of 2. So the side lengths are MO equals 2, NM equals 2 square root of 2, and ON equals 2. So the trigonometric ratios for theta in triangle MNO are sine, which is 2 over the hypotenuse, 2 square root of 2, and it's simplified. Make sure that you get all of the square roots out of the denominator, okay? So I have cosine, which is 2 over 2 square root of 2, which becomes square root of 2 over 2. Tangent theta becomes 2 over 2 or 1. Cosecant, you just flip it, so it becomes 2 over 2. Those cancel out, so I'm left with the square root of 2. Secant becomes the square root of 2, and cotangent is 1. So in a 45, 45, 90 degree right triangle, since the two legs are equal, sine theta equals cosine theta, cosecant theta equals secant theta, and tangent theta equals cotangent theta, which equals 1. Check your calculations. Use a calculator to evaluate both sine at 45 degrees and square root of 2 over 2. They should both be approximately equal to 0.7071. Okay. BJKL is a 30, 60, 90 right triangle with side lengths LK equals 4 and M, the measure of angle J is 30. What are the 6 trigonometric ratios for angle J with measure theta? Okay. So the triangle is half of an equilateral triangle, so the length of the hypotenuse is twice the length of the shortest leg. So we know that JKL with theta being 30 degrees, KL or LK is 4, the hypotenuse is double that, which is 8. Use the Pythagorean theorem to find the third side or third leg. So I get a squared plus b squared equals c squared. So 4 squared plus b squared equals 8 squared. So b squared equals 48, or b equals 4 square root of 3. So the side lengths are JL equals 4 square root of 3, KJ equals 8, and LK equals 4. So the trigonometric ratios for theta in triangle JKL are sine of theta equals 4/8 or 1/2. Cosine theta equals 4 square root of 3 over 8, which simplifies to square root of 3 over 2. Tangent theta equals 4 over 4 square root of 3, which simplifies to the square root of 3 over 3. Cosecant is 8 over 4, which simplifies to 2. Secant theta equals 2 over square root of 3, which simplifies to 2 square root of 3 over 3. And cotangent theta equals the square root of 3. All right, so let's try it. The length of the hypotenuse in a 45, 45, 90 triangle is 5 square root of 2. What are the sine and secant ratios for a 45 degree angle? So they gave me a 45, 45, 90, and they told me the hypotenuse is 5 square root of 2. Okay. So I know since this is a 45, 45, I know that my legs are going to be the same. So when I have my a squared plus b squared equals c squared, I know that these a equals b. So this is really 2a squared equals c squared, because I'll have 2 of them. I can really write a squared plus a squared equals c squared. So c is 5 square root of 2. So 5 square root of 2 gives me 50. I divide both sides by 2. So a squared is 25. So a equals 5. So this is 5 and this is 5. Okay. Then they asked me for sine and secant. So sine theta, remember, is opposite over the hypotenuse. So this is going to be 5 over 5 square root of 2. But remember, I can't have square root of 2. I need to multiply both of these by square root of 2. The 5s are actually going to cancel, so I'm left with 1 over square root of 2, which gives me the square root of 2 over 2. And then secant is, so secant is the reciprocal of cosine, which is hypotenuse over adjacent. So my hypotenuse is 5 square root of 2 over 5. Cosecant. No, sorry, secant theta. Okay, which simplifies to the square root of 2. All right, example 5, explain trigonometric identities. So which trigonometric ratios are reciprocals of each other? So an identity is an equation that is true for all values of the variable for which all expressions in the equation are defined. You have seen that some trigonometric functions include ratios that are reciprocals. So one example is sine theta equals opposite over hypotenuse, and cosecant theta, which is hypotenuse over opposite. I can show that the following reciprocal identity is true for all values of theta that measure an acute angle. Sine theta equals 1 over cosecant theta. I can confirm that the equation is true algebraically by using substitution. Sine theta equals 1 over cosecant theta, which equals 1 over a hypotenuse over the opposite, which when I simplify that equals opposite over hypotenuse, which is the definition of sine. B, how are the trigonometric ratios of the two non-right angles in a right triangle related to each other? So alpha and beta are complementary angles. Alpha plus beta equals 90 degrees, so alpha equals 90 degrees minus beta. Beta equals 90 degrees minus alpha. So the Greek letters alpha and beta are often used to represent angles in trigonometry. Compare sine and cosine for alpha and beta. Sine of alpha equals zx over yz, where the cosine of beta equals zx over yz. Cosine of alpha equals xy over yz, and the sine of beta equals xy over yz. So you can see that they're switched. So alpha, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, whereas for beta, I have opposite over hypotenuse or adjacent over hypotenuse. If beta equals 90 minus alpha, then sine alpha equals cosine beta and cosine alpha equals sine beta. The trigonometric function for the complement of an angle is called a cofunction. So these are the cofunction identities for sine and cosine. C, triangle DEF has right angle F. The measure of angle D is alpha and the measure of angle E is beta. If sine alpha equals 8 over 17 and cosine alpha equals 15 over 17, find sine beta and cosine beta. So in a right triangle where alpha and beta are complementary angles, sine alpha equals cosine beta and cosine alpha equals sine beta. You are given sine alpha equals 8/17 and cosine alpha equals 15/17. Use this information to determine that sine beta equals 15 over 17 and cosine beta equals 8 over 17. You can confirm your findings by sketching one possible triangle that represents the situation. In this example, the hypotenuse is 17. The side opposite alpha is 8 and the side adjacent to alpha is 15. For this information, you can confirm that sine beta equals 15 over 17 and sine alpha equals 8 over 17. All right, let's try it. What are the cofunction identities for tangent and cotangent? Okay, so we know that tangent equals, the opposite is cotangent of 90 degrees minus theta. And cotangent theta equals the tangent of 90 degrees minus theta. Concept summary: trigonometric functions and acute angles. So in words, the ratios of the sides of any right triangle are always the same for the given angle theta. These ratios define the 6 basic trigonometric functions. So in definitions, I have sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, tangent, which is opposite over hypotenuse. You can also remember using the acronym of SOHCAHTOA, SOHCAHTOA. The cosecant is the reciprocal of the sine, which is the hypotenuse over the opposite. The secant is the reciprocal of the hypotenuse over the adjacent, and the cotangent is the reciprocal of the tangent, which is adjacent over opposite. And that is the end of Unit 7, Lesson 1.